So when I say we're calculating volume, what are we calculating?
The surface. Well, you're calculating a unit of measurement of how much object or a subject takes up space.
Yeah. So we've always described it as like how much space something takes up, right? Like if you were filling it up with something. So for instance, on like previous questions, it was like, here's a box, you're filling that box with water. I always just say water. But you can be filling it with anything, right? Gentlemen. So what is volume? Stop. Thank you. So what is volume? Is how much space something takes up. Or you're filling. Same idea too. Before today, we always just kind of had like a shape, right? You're feeling like a cone or a sphere or a box or something very basic. Today is going to be a little bit more complex. We're going to have like shapes within shapes, shapes with parts cut out of it. We're going to have like staircases, all kinds of more applicable things. So this first one says a hole is drilled in a cube as shown below. If the cube has a side length of 20 and a radius of the hole out of the cube, and the radius of the hole cut in the cube is 5 centimeters, determine the volume of the remaining shape. So you've got a cube with side length 20. I'm going to put that on my little drawing. Because it's a cube, that means all sides are 20. That's important. Cube, all sides are the same. And the radius of the hole cut in the cube is 5 centimeters. So that means this little hole in the middle, from the center to the edge, is 5 centimeters. Determine the volume of the remaining shape. What they're asking you for is this area, the volume of this inside shaded thing. So we had a cube and then we cut part of it out. So you're trying to figure out that remaining volume. Yeah.
You just like calculate the square and then the cylinder separately and subtract the cylinder from the square.
That's exactly what you're going to do. So Jordan said you're going to take the cube, volume, and subtract the cylinder volume. And that'll give you that remaining piece. So do the big object, subtract out that hole that you cut through the middle.
How tall is the cylinder?
Good question. We're almost there. Cube. To calculate the volume of a cube is length times width times height. That's 20 times 20 times 20. Which I believe will be 6,000. Then you want to subtract.
That would be 8,000.
Is it 8? It definitely is 8. I was adding. Thank you. Then you want to subtract the volume of the cylinder. The cylinder should be on your formula sheet. I don't expect you to have everything memorized. The way we did a cylinder was it was the circle, right? The area of the circle, then timesing by the height of whatever that thing was. It is in here. It's right there. Make sure you're looking in the right column, right? So cylinder and then volume. The formula for volume of a cylinder is pi r squared h. When you're looking to do that, r is the radius. It's 5 squared. And then Jaden asked, what's the height? So when you're looking at this cylinder, the height was actually kind of like the depth, like how deep in that thing goes into the cube we got. For us, it's 20. Right? The height would be the exact same depth as that cube. So the height is 20.
Because I guess the height of the cube.
Exactly. Like if you were, and you can always move these objects to help you. So if you want to stand that object up, sure, move it. Like move it in your head envision what it looks like. If you calculate that, so you got pi times 5 squared times 20 gets you 1570.796. Now your last step is to actually subtract those two numbers together. So you're going to go 8,000 minus that big number will give you the remaining volume, which is 6,429.2 centimeters cubed. What's up, Reese? What are you thinking?
I don't know what's up. I just gotta do canals.
You got the 8,000 part, right?
Yeah.
When you did the red part, and this is important, so our calculation on that, you might want to do like this calculation first.
I don't know if I quite explained it.
I got a different answer too. I didn't do that.
You're trying to determine times money or remain.
Didn't times by the height? What'd you get?
12,000. No.
I know that got
78.5. 66,370 decimals.
Are you, when you're calculating these things, the way I'm chunking it, like, is important. If you're trying to throw this whole shebang in your calculator, like, it's almost a guarantee it's not going to go well, right? So my guess is that probably somewhere that big. Did you do a big calculation?
Well, I did 8,000 times pi times 5 squared times 12.
Oh, instead of subtracting all that times
I
together.
subtract.
Yes, this represents the cylinder. And then I'm taking the cube, which is my big shape, and I'm subtracting that hole in the middle.
Oh, yeah, real dumb.
So you're trying to find the difference between the two.
And that's the difference between the two, right? So Reese, we're good now? Jaden, we're good now?
Yeah.
Beautiful.
With
This one. So this one says a new canal is being dug out to help the flow of water. The canal is pictured below. How much water does it take to fill the canal? If you look at this thing, I have no idea what shape that is. And whenever you get something that's a weird shape like that, you've got to draw your own imaginary lines somewhere. For me, I can kind of tell that if I put a line right here, what I'm doing is I'm creating a rectangle and then half of a circle. So that means if I drew another line from here to there, now I can see I've got half a cylinder on the top, and I've got a square or a rectangular prism on the bottom. And when you get these weird shapes, it's up to you to kind of figure out how you're going to draw it so it's a shape we know.
Yeah, because is that half of this rectangle or like more than?
When you're looking at that cylinder on the top,
No, the rectangle.
the rectangle, we can calculate the way it is. It's very shrunken. It's a very short one. But we'll just use those numbers that they gave us to be able to do that prism.
Have all equal sides or still be rectangles?
So if you want to figure out this entire thing, what you want to do is you want to calculate the volume of that rectangular prism. And then you want to add the volume of that half cylinder on the top. The cylinder is going to be hard because there's going to be some tricks we need to use to it. The rectangular prism is not going to be too bad. We'll start with the rectangular prism. Formula for that rectangular prism is length times width times height.
Yeah, because it doesn't give you a radius.
Right. So
Wait,
that,
no, then that's just half a 5.
so it's 3 times 5 times 20. If you throw that in your calculator, thank you. The rectangle is 300, and that would be obviously centimeters cubed, but we're just going to say 300 for now. The cylinder is going to be the harder part.
I was just going to say that the diameter of the half circle would be 5 centimeters.
Exactly. So when you're looking at the cylinder, we know that the cylinder, we want to do half of pi r squared h. This 1/2 represents half. It's only half of a cylinder. And then you have your cylinder formula. The radius is not easy on this one. Because when you look at your cylinder, they never gave you a radius. They never explicitly said, here's the radius of the top part of that cylinder. Instead, what you need to realize is this line of 5 and this line of 5 would be the same. And that actually represents the diameter, right? Because it's all the way across. So if you want the radius, it's half of that. So the radius from here to here is 2.5. Yeah. Now I can put in my numbers. I got a half times pi times 2.5 squared times 20, because that's how long that thing's going to be. Again, break your calculations up. So when you go to calculate, like do that blue one in whatever chunks make sense to you. For me, it might be easier to go 2.5 squared, then multiply by 20, then multiply by pi, then multiply by half. You can multiply in any order you want. Yep.
I was going to say it's easier for me to do the equation like normal than divide that by 2.
Yep. And if you want to divide by 2 instead of timesing by that 1/2 that I have, that works too. As long as you're getting a value of 196.349. ... Again, if you use 3.14, it's going to be slightly different, but that's okay. You're adding these together because this time we want to do this prism plus this half cylinder. When you add those numbers together, you should get 496.3 centimeters cubed. That would be the volume of that canal. That's how much water it would take to fill that thing.
Wouldn't that be... I got it right.
So if I'm looking to round to 10, I look beside it. If it's less than 5, then I don't change it. That's what sometimes people like double round it. You only ever want to round once. So just look once over.
What's the circumference of the sphere for the next one? I guess so.
Just wait. Yeah, wait till we get there. All right, number 3. Do you need that? Here. Sorry, bud. Keep going. The trick with these word problems is they're not always going to give you all the info up front. Right? Like you got to work for it a little bit. So sometimes you're going to have to go to your formula sheet and you're going to have to work through it and be like, okay, that's how I calculate that. And they are going to make you struggle a little bit. Am I good to scroll down? Take it, sir. Number 3. Mr. Kennedy orders a glass ball on Amazon and it comes in a cute box. They fill the package with bubble wrap to make sure that the ball doesn't break. How much bubble wrap do they need? So if you're picturing filling a package, what you're doing is you're taking this cube and you're trying to fill all the gaps around it, right? Essentially what you're doing is you're taking the cube and then subtracting what the sphere already takes up, or the ball in this case. And what that gives you is the remainder that you need to fill up. Volume of a cube, we're good at, right? Volume of a cube, length, width, height.
But it's not a cube because they're not all the same. Oh yeah, that's right.
Sometimes I say cube and I'm wrong, dude. Just say it.
I did not.
So that's 12 times 12 times 12 at 1,728. The sphere. Sphere's harder.
Our sphere's 4 pi r squared.
Yeah, I think you're right.
4 pi r squared.
That was
No,
spheres.
for volume it's 4 pi r squared.
Pi r cube.
Pi r cubed
and it's
divided by 4.
So sphere on your formula sheet, you want to go find your sphere. It's the very last one on your formula sheet. You're going to go all the way to the right, and you're going to find that the volume of a sphere equals 4 times pi times the radius cubed, and then divide that answer by 3. It's the hard one to remember, the easy one to calculate, right? Those spheres, cones, they're the hard ones to remember what the formula is. But once you read the formula, they're the easier ones to calculate. Plugging this in, that means it's 4 times pi. What is the radius of that sphere?
6.
6. How'd you get 6?
That's
Just half as well.
Yeah, you're right. So because the box is 12 by 12, that means if I'm in the middle of the sphere and I went to the outer edge of that box, it would be 6. It would be halfway. So it is 6 cubed. And then we divide that by 3. Throw that in your calculator. It's going to be a bit of a nightmare to calculate. You should get... Oh, sorry. I messed it up on my own. $904.778. ... I marked your quizzes yesterday. The surface area ones.
Yeah, I got 72. What's that deal?
That's pretty good.
No, not
Do you
this.
have our powers?
Yeah, it's. I don't. I'll see if I can get it though.
Some power thing.
Marking those quizzes. When you guys did surface area of big calculations and you had things like this, you showed your work and your work was right, and then your answer was wrong. So that means something's going on in our calculators. So when we're doing these practice questions together, try putting it in your calculator so that you see what you're getting. Because if you're not getting the same thing, we need to fix however you're doing it in your calculator. And every calculator is different. So we need to work together to figure it out. Get it? I will, yeah.
Because I don't have a phone, so I can't look at my-
Yeah.
I was gonna
I'll
say,
handle
I
that.
can't. Exactly.
I'll hand all your quiz notes. So you always have everyone.
Quick question. Are those spheres or circles?
Spheres. If you calculate this, 1728, and then you subtract your answer, you get an answer of 823.2 inches cubed. So that's how much bubble wrap they would need. Reese. Thank you. 823.2 inches cubed. That's how much bubble wrap you'd need. The gaps in the packaging, right? So you'd be filling that whole box so that nothing spills out. Yeah, Laura. Did you get the green answer the same as me? 904.778? Yeah? And the 1728 you got the same? What'd you get as your answer? 903. All right.
Nana, how much saving in a pizza?
I feel that.
You're making me credit PTO.
Number 4, I want you to try on your own. I'm going to give you a hint.
How about I try it? No,
Ladies and gentlemen, I'll give you a hint to help you start it. It says, if the radius of a tennis ball is 2.7 inches, determine the volume of the empty space in the can of tennis balls. if the radius is 2.7, that's from the middle of a tennis ball to the edge is 2.7.
So you just like calculate one and then like times that by 3.
You could, yeah.
Or you can
The harder part is going to be the cylinder because they didn't give you any measurements for the cylinder. The height of the cylinder is going to be equal to all of those radiuses added up, right? So if I did 2.7 plus another 2.7 plus another 2.7 plus another 2.7,
Wouldn't the radius of the cylinder be the radius of the circle?
and the radius of the cylinder would be the same, but the height's going to be that tricky part. So it's all the radiuses together. Okay, I want you to try to calculate that one. So if you can try to calculate the cylinder, then you're subtracting away the 3 balls to get the empty space in the can. When we look at this one, we're going to start off by calculating the volume of the balls. So we're going to do those sphere calculations. Because there's 3 of the balls, we're going to do times 3. Then we're going to, sorry, I want to put that over here.
I should put down 3 of the numbers beyond the decimal point, right?
Yeah. Then we're going to subtract that away from the tube or the cylinder. I want to do that in red, so it's a different color. We'll start off with that big cylinder. So the formula is pi RH, pi r squared h. We knew that r was 2.7.
Oh my god.
We didn't know what height was, so we talked about that. The height was all those radiuses added up. So when you came over here and you added all those radiuses, you should have got a height of 16.2. Right, that's adding all those radiuses.
What's the length of it?
I'm not there yet. So then you would have got the tube to be 371.015 ... When you go to calculate the cylinders or the balls, you're doing your formula, which is pi times the radius, which is 2.7, times the height, which we already figured out was 16.2. And we're timesing that by 3 because there's 3 balls there. When you calculate that, 2.7 squared times 16.2. What the heck? Y'all were going to just let me do the wrong thing. Yeah, I know. I was doing the wrong formula. I was doing cylinder. The balls is 4 pi 2.7 cubed divided by 3. And then we're timesing that guy by 3. So 4 times pi times 2.7 to the power of 3. Divided by 3 times by 3, you should get 247.343 ... Again, like the calculations, they're not easy to do. So try them on your phone or on your calculator, whatever you got, because you've got to figure out where they're going right, where they're going wrong. And if you're not trying them on your own, then the only time you're trying them is on a test. And then you're bound to like set yourself up for failure, right? So try them with me. And you're like, wait a minute, I'm not getting that number. Because something's going on with your phone. If you're using 3.14 instead of pi, then you're going to be slightly different than me. And that's okay. You would get like 240 or something like that probably?
I got 247. 218.
Oh, okay, that's tight then. So you use 3.14? Yeah, then that's, you should be like just the decimals wrong there, is what you said.
This is why I write down.
Now when you do the subtraction, so you got 371.015 and we're subtracting 247.343, you get the remainder space of 123.672. Yes, sir. Yeah, I'll hand him out in a second. Yeah. Yes, sir.
I think I just wrote something wrong. I was like one decimal.
Yeah, that's probably all it was. Yeah. You're fine. When you guys do your test, if you're like a decimal point off, honestly, I'm giving it to you. Like, I could care less about if you use 3.14 instead of pi. I could care less if you rounded just slightly different. That's not what I'm testing for. I'm testing, do you understand what volume is? Can you calculate volume? If you can do that, I'm happy camper.
For some reason, when I added all three, it was all the way on like 700.
That's because, yeah, did you do this division?
Yeah.
Okay, and then did you times by 3?
Yeah.
Okay, then that's all 3 balls. So now by adding it again, you did 9 balls. You did 3 balls, then 3 balls, then 3 balls. By timesing by 3 here, we covered the fact that there's 3 balls. So you don't need to do it again.
I had to do that like after.
No, that's okay. You don't need to do that one again.
Do these formulas work in real life?
Yeah. Like, that's how you legit calculate things. All right. Ice cream cone. A spherical scoop of ice cream is put in an ice cream cone. If the ice cream melts, will it overflow? So you've got this cone. If it melted, it's turning to liquid and it's filling up the cone. To tell if it's going to overflow, you got to figure out which volume's bigger. Is the volume of the ice cream scoop bigger than the volume of the cone? If it is, it's going to spill. If it's not going to spill. So you're really just doing a comparison between the two.
It depends if it's just on top or if it's a large cone.
Assume it's going all in the middle. 5 inches is a pretty big ice cream cone. So we'll do the scoop, the ice cream,
So just divide it by 2.
versus the cone. The ice cream is a sphere, it's a ball. So our formula is 4 pi r cubed divided by 3. Right, that's the volume for a ball or a sphere. The radius in this case is 1. So it's 4 pi times 1 cubed divided by 3. When you calculate that, you should get 4.188 ... Divide by 3. And we're comparing that. So versus the area of the volume of a cone, which we haven't calculated yet today. So a reminder that the volume for a cone is pi r squared h. And that h is the vertical height, not the slant height. So it's from like the top to the bottom. For this question, that's what they provided you. So you should be set. When you go to calculate that, that's pi 1 squared times 5 divided by 3. You get 5.235 ... So when you compare that, you've got your sphere, your ice cream, and you've got your cone. That completely melts and fills up that cone. Will it spill over the top or will you still have room? Yeah.
Well, it's just depending on how much the space is compared to the cone to the ice cream. So if you have more space in the cone, you
Should be safe.
should theoretically be safe for.
So do we have space in the cone? Theoretically.
Yeah.
Theoretically, the cone is bigger, so we should have space. And you're right, like that is always in theory, right? Because if there's like that cone's really thick or something, like I don't know, there's things we don't know. But theoretically, this cone holds more than that one scoop.
Yeah.
So it will not spill.
Is there any question where you actually need the diameter of a circle?
For us, I don't think we do use the diameter very much, do we?
We always split.
Maybe
in half.
circumference. We're always cutting it in half. I think you're right. I don't think we ever use it. I mean, in other worlds it might be useful, but not for us. Yeah, we never use it. Awesome. This one. A time capsule shaped like a pill is shown below. How much stuff can fit in the time capsule? When looking at that, you're trying to fill this thing up. You need to break it into its shapes. When I'm looking at it, I have a cylinder here.
Can you just like do like one full circle?
Yep.
And, like, maybe-
So I've got this is my cylinder. Plus I have those ends. And if I look at these ends, what I've got is I've got two half cylinders. So if I think about that, those two half spheres creates one ball. But you have to envision that. Like, how can I break that shape up? Honestly, you guys are better at that type of stuff than I am. Like, my brain just does not function that way. I'm not good at seeing things like that, where I could take objects apart. My brain just doesn't work that way. Right? Where typically you guys are better than that.
Do you not divide it by 3 then?
So you see that, and you see those two pieces. You still got to follow the whole sphere formula. So you still got to divide by 3. Our cylinder, our formula, I think I'd know it by now, is pi r squared h plus the sphere, which the sphere is 4 pi r cubed.
Do you just do 4 pi or do 4 times pi?
4 times pi. If you put in your calculator 4 pi, I think it still works, but I don't know. It's 4 times pi. When I do that cylinder, that's pi times 2 squared times 5. If you put that in your calculator, you should get 62.831 ... On the blue side, when you calculate that, you should get that sphere is 33.510. For a total of 96.3. And that's feet cubed. It's a big time capsule. Of course. So when you get those composite shapes, break them up into what you know. Right? There's always got to be some way to cut it. Always. Has to be. Got the last one here. What would the shapes be that I break that one into?
Rectangle and half circle.
I got a rectangular prism.
Half cylinder.
Yeah. Down here, I've got my rectangular prism. Plus, on the top, I've got this half of a cylinder. Length times width times height gives me my prism. My cylinder formula is half of pi r squared h. I want you to try to finish that question off, and I'll hand out your practice for the day.